Moving right along into 7.3, this deals with properties of logarithms. And we have a handful of properties that we're going to have to keep track of from this section. We have properties such as the change of base property that we're going to kind of go briefly through, but it's going to help in 7.4 for solving equations. And then also this objective 2, you need to know how to expand and condense logarithms. This one is our key. We really do need to keep track of how to expand logarithms. A majority of the homework problems are dedicated to that. As we get into chapter 8, this ability to expand logarithms is going to become very helpful. So stay focused with that objective throughout this. What we're going to tackle first is the change of base property. And to start out with, I just want you to consider these two equations. These two exponential equations. For a problem like this, as an exponential, it's solvable. What we can do is try to build ourselves up to relate these to have a common base. So this is what it would look like. We would have 3 to the x, and we had some of these problems in your last assignment. But we can see this 27 and 3 are linked by the common base of 3. This would technically be 3 to the 1 to the x, and this one right here would be 1 over, and then I could rewrite 27 as 3 to the 3. Alright, and then using some of those exponential properties, I could cross a line, change the line. So what I would get is 3 to the x is equal to 3 to the negative 3. Being that these are a common base, what I can go ahead and say is, well, then these would have to be equal to each other. The only thing that x could be would be x to the negative 3. So here, this exponent would be 3 to the negative 3. Yeah, well, that does equal 1 over 27. Versus an equation like this. If I were given something like this, I have no kind of common base between 3 and 7. There's nothing I could rewrite either one of these as in order to get some sort of common base. So this one would require a logarithm. Alright, so I am going to take the log base 3 of both sides. That would undo this exponential, and I could get my x by itself to figure, alright, well, whatever I do to one side, I have to do to the other, log base 3. I have gotten my x to be this number right here. So we do have an issue because a lot of calculators do not allow us to do a log base 3. It's the same reason we don't have a divided by specifically 3 in our calculators, because you would need to have a divided by all of our numbers. So there's no way to possibly fit all that into a calculator. So same thing here, we need some sort of method on plugging this into our calculator. Which brings us to this. It's the change of base property. It states you can rewrite a logarithm of any base as a ratio of logarithms of another base. My best way to do this is you have this property on that first page of this chapter. It is, let me see. You have it on page 477. But the best way to look at this, I believe, is through example. So I'm going to go ahead and do example 1, and it asks you to evaluate the logarithm using change of base formula. So they gave us this logarithm right here, a log base 3 of 7. What do you know? It's the same as our example up above. So once again, we have no log base 3 specifically on our calculator, but what I could go ahead and do is I could change this log base 3 into a log base 4 over, I'm going to highlight this in red, whatever our log is, whatever log we're taking a logarithm base 3 of 7, so it would be your big number, that whatever we're taking the log of, over, and then as long as you align this to have the same type of logarithm, so if I chose log 4, I want to rewrite this log base 3 into a log base 4 ratio, I could do that. Then it's just going to be the big over that original base. So I'm going to choose this original base to be 3, so here this is what we would be looking at. We have changed this logarithm base 3 into a log base 4 ratio, and then we took whatever we're taking the log of, over the original base. I could have rewritten it like this if I wanted to. Log base 6. Why not? Log base 6. So it's a ratio of log base 6's, and once again it would be your whatever you're taking the log of over that smaller little base number. So 7, 3. All right, but the problem is these still don't help us because we still don't have a log base 4 in our calculator. So the idea is you do have a common log button, which is just a log, and this technically is a log base 10. And then we also have a natural log button, which is a log base e in our calculator. The natural log is something that would undo an exponential base e. So if I ever wanted to undo a base e exponential, I would take a log base e, but this isn't how we notate it. Exponentials base e happen so much in real life that we've given it its own logarithm. So natural log is equal to log base e. So this natural log is what would undo an exponential base e. Alright, so the way I could set this up is I could take the natural log over the natural log of, once again, 7 over 3, or I could also just take the common log over the common log, which is a base 10 logarithm of 7 over 3. Either one you type into your calculator will get you the same approximate answer of 1.77. And I believe they say to the 3 decimal places, sorry, so 1.771 is your answer to number 1. Alright, just like we had properties for exponentials and exponents, once again, here's a flashback to what those are. I'm going to go ahead and look at this real quick. And what this basically stated is if you ever had two exponentials of the same base that you're multiplying, then what you could go ahead and do is just combine them into one exponential and then just add those exponents. Alright, it works a little bit backwards when we're talking about logarithms, so I'm going to move this and see if I can't fit them all. Okay, so here is one of our product properties of logarithms, and here's what it states. If you ever have a logarithm of some sort of base and there's two things being multiplied, so we'll look at examples of these, but if you had a log of some sort of base and then there's two factors that you're taking the logarithm of, then what you can do is you can expand it into two pieces where you're just taking the log base of that one of those factors plus the log base of that other one of those factors. So this kind of spawns, the product property of logarithms spawns from the product property of exponentials. Alright, we have another one. It's the quotient property, and if you can remember, if you ever had some sort of exponent a over n, a to the n over a to the m, so if you ever had something like this, you could go ahead and subtract those exponents. So the quotient property is very much related. If you have a logarithm of some sort of base of a quotient, what you can do is you can subtract, you can break up that quotient into two separate logarithms, expand it out, and then just subtract them. We also have the power rule. This has to do with the power of a power rule with this right here. If you ever have a power of an exponent up to another exponent, what you can do is multiply those exponents. This is going to be, there's proofs that link these, but we're not going to go into them. But if you ever have a logarithm base of some sort of power, what you can do is take that exponent down and bring it as a multiplier to this whole thing. And finally, the equality. If you ever have a log base b of m equaling a log of that same b base of some sort of other number, then those have to be the same. Alright, so we're going to look at examples of these. So I've kind of condensed these properties down into the main ones that I'm concerned with that I really do want you to establish before we move into Chapter 8. So these properties are very important to review. And number 23, we're just going to show this by example. I have a log base 10 of 5 times x. So what you can see here is that I'm taking a logarithm of two factors. It happens to be a log base 10. So what I can go ahead and do is use this product rule. If ever you see that you're multiplying two things within a logarithm, then you can go ahead and expand it. You keep the same base, and here's my first factor, and then we add the log base 10 of x. So that's done. That's as expanded as it gets. Okay, so number 33, when you're looking at this one, what I have is I'm going to have to do a rewrite. I don't want you to be startled by this natural log. A natural log, once again, if you feel more comfortable, look at it as a log base e of a minus 1, e being just a number, so it still takes these rules in. It's still applicable to, or these rules are still applicable to it, so I can still go ahead and use them. I am going to have to rewrite this though, so I'm just going to keep it as ln because I'm fine with ln. But this I'm going to rewrite as a minus 1 to the 1/2. Alright, so being that this is a grouping that's all square rooted, I can rewrite it like this, and this is going to be an example of where we have a power, alright, of some sort of expression or number. So I'm going to take that out and bring that to the front, 1/2 the natural log of a minus 1. And what I am afraid that you see here is that you might try to go in and break this apart by dividing them, doing the natural log of a divided by the natural log of 1. Can't do that. We don't have any properties that state that we can do something like that. So once again, we could go into the proofs of all of these. These are all provable. These are all these are all concrete properties that are true. That, I mean, this will equal out this. If you wanted to type into your calculator, for example, if had this been a 2, okay, so log base 10 of 10 would equal a log base 10 of 5 plus a log base 10 of 2. You could go ahead and see that these are true. It's a true statement. This is as far as it goes, okay? So don't try to break it into anything else. These are the only properties that we are limited to. 40 is a tricky one. That's getting pretty tricky, but I do want you to try that. I am going to point your direction to number, let's say, 49. Alright. The last set that I gave you, problems 43 through 51, are actually going to be, instead of going this way with it, we're actually going to condense the expression. So this one's 49 is a little questionable if you're really condensing it. But what you have is a log base 3 of 5 times x, and what they really just want you to do is take this and work backwards with those properties. So being that we have this multiplier of 1/4 to this logarithm, you could go ahead and put it as an exponent. So this would just be equal to log base 3 of 5x, this whole quantity, to the 1/4. Okay, that's all this one was asking you to do. And I think I'm going to stop with that. Okay, so that is the properties that you need to kind of keep track of. Here they are again. Here are some examples of them, but you're just working with the properties in this chapter.